Hi everyone, and welcome to today's lesson on real numbers. In this lesson we're going to be naming subsets of the real number system and identifying numbers that will belong in each of these subsets. So the first thing we want to do is get a couple of definitions that go along with our objective for today. A set is simply a well-defined collection of objects or numbers. Each item within that set is called an element of the set. Within a set of numbers, you can have what's called a subset. That would be a group of objects or numbers that's part of a larger group. For example, I like to think about a cake. Within cake, there are several different types of cakes that you can buy. Chocolate cake, white cake, marble cake. These would be subsets of cake. So we're going to be talking about real numbers. Basically, real numbers are all of the numbers that we've discussed in math. Within the real numbers, there are something that we call rational numbers. Rational numbers are any number that can be written as the ratio of two integers. The word ratio, remember, simply means that you're comparing one quantity to another, or in other words, any number that can be written as a fraction. So any number that can be turned into a fraction is a rational number. Now that does not mean that every rational number must be a fraction. For example, within the rational numbers, there are even smaller subsets. The first subset is called the whole numbers. The whole numbers are all of your counting numbers plus 0. They include the numbers 0, 1, 2, 3, and so on, counting upward. Notice, these numbers are all rational numbers because I could write them as a fraction by putting them each over 1. 2 over 1 is 2, which would make it a rational number. We have the natural numbers. The natural numbers are very similar to the whole numbers, but they do not include 0. So natural numbers begin at 1 and count up by ones. A third subset of the rational numbers is called the integers. Integers are all of the whole numbers and their opposites. In other words, integers include negatives. But again, notice, none of these subsets of the rational numbers include any fractions or decimals. So a rational number can be a fraction. A rational number can be a whole number. It can be a natural number. It can be an integer. If a number is not a rational number, it is what we call an irrational number. An irrational number is any number that cannot be written as a ratio of two integers. There's basically one kind of number that we know of that cannot be written as a ratio of two integers, and that's our non-terminating, non-repeating decimals. So, for example, up here with rational numbers, we would include numbers like 2.7. 2.7 is a decimal, but it could be written as 2 and 7/10. So it's still a rational number. Repeating decimals, like 0.3 repeating, those can also be written as fractions. That is the fraction 1/3. So again, that is a rational number. If you have non-terminating, non-repeating decimals, those are irrational numbers because they cannot be turned into fractions. So some number like this that just kept going and going and going and didn't have an end, but no pattern either, those are your irrational numbers. Things that we tend to think of when we think of irrational numbers, numbers that have square roots that do not come out to whole numbers, like the square root of 27. If you were to put that in your calculator, you would get a non-terminating, non-repeating decimal. Let's look at this a little different way. Within the real numbers, there are two basic sets of numbers that every real number must be. It must be either a rational number or it must be an irrational number. Within the rational numbers, there are some smaller sets. You have the integers, which include all the negatives and the positives of the whole numbers. You have whole numbers, and you have natural numbers. Now let's talk about some numbers we could put in here. Let's say I gave you the number 5. The number 5 is a rational number because it could be written as 5 over 1, which would be a fraction. 5 is also an integer. 5 is a whole number. 5 is a natural number. So since it fits all of these boxes, I'm going to put it in the smallest box because that indicates that 5 is not only a natural number, but it is also a whole number, an integer, and a rational number. Now let's talk about something like negative 4. Negative 4 is not a natural number. Natural numbers do not include negatives. Whole numbers do not include negatives. Integers do include negatives. They include all of the whole numbers and their opposites. So since 4 is a whole number, negative 4 is the opposite, that would be an integer. That means that negative 4 is not only an integer, it's also a rational number. If I give you a decimal, like 2.5, 2.5 would be a rational number because I could write it as 2 and 5/10. It is not an integer, it's not a whole number, it's not a natural number. So the only set it would fit into is the rational numbers. Remember, all decimals that are terminating, meaning they end, or repeating belong in the rational numbers. All fractions are rational numbers. For example, 2/5 is a rational number. Irrational numbers would be non-terminating, non-repeating decimals. This is a common irrational number that we know. Pi. It's 3.14159 and it just keeps going and going. That's an irrational number. The square root of 32. 32 is not a perfect square, so the square root is a non-terminating, non-repeating decimal. That would go there. We've left one box blank, and that's our whole numbers. Let's talk about finding a whole number that does not fit in the natural numbers. Most of my whole numbers are also natural numbers. For example, 3. 3 is a whole number, but it's also a natural number. 17 is a whole number, but it's also a natural number. There is only one number that's a whole number that's not also a natural number, and that's 0. 0 belongs in the whole numbers. It does not belong in the natural numbers. And the way this works tells me that 0 is a whole number, 0 is an integer, 0 is a rational number. So let's practice a few of these. You can use this diagram to help you as we go. Negative 4. Negative 4 is a rational number. It can be written as a fraction if I put it over 1. Negative 4 is an integer. So I know it's rational. I know it's an integer. Negative 4 is not a whole number, which means it also cannot be a natural number. So this is the only two subsets that work. 3 over 5. Since 3 over 5 is a fraction, it is automatically a rational number. However, if we look at the other subsets, it doesn't belong in any of the others because 3 over 5 is not an integer, it's not a whole number, it's not a natural number. So that's the only subset that belongs. The square root of 43. If we take the square root of 43, we get a non-terminating, non-repeating decimal. So I know that the square root of 43 is irrational. There are no other subsets when we talk about irrational, so we're done. 3.7. Since 3.7 is a terminating decimal, it can be written as a fraction, making it a rational number. That is the same as 3 and 7/10. It is not a whole number, it's not an integer, it's not a natural number, so that's my only answer. 0. We could place 0 over 1. 0 is a rational number. 0 is also an integer. Remember, integers are all of the whole numbers and their opposites. And 0 is a whole number. Remember, whole numbers start at 0 and count up. The square root of 36. Now notice the square root on the last page was actually an irrational number, but since the square root of 36 is 6, this is a rational number. The square root of 36 is also an integer. It's a whole number. And it's a natural number. It belongs to all of those. Pi, we talked about this just on the other page. Pi is a non-terminating, non-repeating decimal, which automatically makes an irrational number. So this is how we decide the subsets. Remember, this little diagram here can be very helpful when you are trying to decide what subsets to name. If something is a part of the natural numbers, it must be a part of all of the sets above it. If something is a member of the integers, then it must be a member of the rational numbers. Irrational numbers and rational numbers never overlap. So if a number is rational, it can't be irrational, and vice versa. So thank you for watching today's lesson, and I'll see you in class.